Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the effect of temperature on the time period of simple pendulum. We know that the time period of a simple pendulum is denoted by 2 pi under root L by G, where L is the distance between hinge point and the center of mass. Okay, so this is L by G, and we are assuming that this ball is a point mass. It does not have any dimension. So this L is the distance between hinge and this point. Now we know that if we increase the temperature, this L will increase, and therefore the time period of this simple pendulum will change. So let us see that at temperature theta 1, the time period was T naught, and T naught was 2 pi under root L naught by G. It was at temperature theta 1. In this case, I am assuming the temperature variable as theta. It is due to the fact that we would not get confused with the temperature and time period T. So at further some other temperature theta is equal to theta 2. So the time period would be 2 pi under root L by G, and T by T naught will be equal to L by L naught root. Okay, and we know that L is equal to L naught 1 plus alpha delta theta. So we can say that L by L naught is equal to 1 plus alpha delta theta, and therefore we can say that T by T naught is equal to under root of 1 plus alpha delta theta. Now we know that alpha is very small, and therefore we can write this as 1 plus alpha delta theta by 2. So we know that according to binomial expansion, 1 plus x to the power n can be written as 1 plus nx if x is very less than 1. So now t is equal to t naught 1 plus alpha delta theta by 2, and t minus t naught by t naught is equal to alpha delta theta by 2. So this is delta t by t naught, and it is equal to alpha delta theta by 2. Now this is the fractional change in time period, or we can also find out the percentage change in time period. So the percentage change in time period is alpha delta theta by 2 into 100. Okay, and what we can do that we can find out the time gain or time lost by the formula T gain or T lost is equal to delta T by T naught into T of a slot. I would explain this thing with an example. So it is alpha delta theta by 2 into T of a slot. Now what is time gain and time lost? We know that if alpha delta theta is positive, so if this expression is positive, which is positive when the sign of alpha and delta theta is same, okay, so if alpha delta theta is positive, then this length has been increased, and time period of the pendulum has been increased. So pendulum clock becomes slow. Because due to the increase in time period, pendulum clock will complete its oscillation in a greater time period, and therefore we can say that it is becoming slow, and therefore it has lost some time. Because let us suppose a situation in which A pendulum clock shows 1 hour in 60 minutes normally, and if we have increased the temperature, then it is showing the complete 1 hour in 62 minutes. So what we can say that it has lost its time by 2 minutes, because it is showing this 1 hour completed in 62 minutes instead of 60 minutes. And if this alpha delta theta is positive, and now we can also write that clock has lost the time. Clock has lost the time. And if this alpha delta theta is negative, which would be negative when the sign of alpha and delta theta would be different, then L will decrease and the time period will decrease. And pendulum clock will become faster. Okay, so it would become faster and therefore it would gain some time. Hence, it would gain some time. Okay, so it would gain some time in this case. And now we can take an example. Let us suppose a situation that in some case the alpha delta theta by 2, or we can say that alpha delta theta is 2 into 10 raised to power minus 4 or minus 2. 1 second. Yeah. So in some case, let's suppose that alpha delta theta is 10 to the power minus 2. Let us suppose this situation. So we know that in this case we have to find out, this is also plus positive. So we know that if alpha delta theta is positive, then the pendulum clock has become slow and time has lost by it. So we have to find out the length of a new day. One new day. So one day normally is equal to we know that it is 24 hours, which can be converted into 24 into 3600 seconds. Okay, and we have to find out one new day. So the length of one new day would be equal to alpha delta theta by 2 into time slot. In fact, that we have to find out one new day, and we know that time lost, in this case time has been lost by the clock. So time lost by the clock in this case will be equal to alpha delta theta by 2 into length of that one day, which is 24 into 3600. So T lost will be equal to 10 to the power minus 2 into 24 into 3600, and T lost is 24 into 36. Okay, so the new day, one new day will be equal to the length of old day, which is 24 into 3600 plus the time lost, which is 24 into 36. So we can take 24 into 36 common, and it is 101. So this is the length of one new day. So this was the complete analysis of pendulum clock and the effect of temperature on the time period of the pendulum clock with the example. In the next video, we'll be discussing some different concept. Thank you.